Hello, this is Mrs. Ringrose, and we are back at it again, learning how to solve linear equations using inverse operations. And I decided to split up the multiplicative inverse into two parts. First thing I showed you was if a variable has a multiplier, if it has a coefficient, then you need to undo that multiplication using division. So in this case, x is 5/2. But now we're going to look at variables that are being divided, and we're going to use the inverse operation to isolate the variable and find out what the variable is equal to. So again, inverse operations, can't stress this enough. You always have to think about what's happening to the variable so that you know what you need to do to cancel it out. So inverse operations are operations that undo each other, right, or cancel each other out. And we're going to continually think about what operation is going to cancel it out to get my variable alone. All right, your first example, you read this as a number divided by 5 equals -2, again, because the fraction means division. So again, you want to think to yourself, what is happening to the variable? It's being divided. So what is going to undo the division? What do we need to do to cancel that out? Well, we're going to multiply. We're going to multiply both sides by whatever the thing is being divided by. So multiply both sides by 5. So I'm going to put a 5 up here, and I'm going to put a 5 on this side. All right, what happens on the left side of the equation is that my 5's cancel each other out because anything divided by itself is 1. And I'm left with t equals whatever -2 times 5 is, which is -10. So I just simplified. And then finally, I'm asking for you guys to check your work. So that means, here's my equation, t divided by 5 equals -2. I'm going to put -10 in for that. Okay, I'm ready to try to put this -10 in here and see if I get that result. Does -10 divided by 5 give me -2? 10 divided by 5 is 2. And because I have one negative, a negative divided by a positive is also negative. So I checked it. All right, next example. Everyone's favorite, fractions. All right, so there's two ways to solve this one. I'm going to show you the quick way first, and then I'm going to show you the long way that some kids have more success with. So the best way to do this is to recognize that p is being multiplied by 2/3, right? What is happening to my variable? It's being multiplied by 2/3. When you want to cancel a fraction, if I multiply a fraction, any fraction, by its reciprocal, so I just flip it over, then what happens is my 2 cancels out with the 2 on the bottom, and the 3 cancels out with the 3 on the top, and I'm left with 1, which is what we want, right? We want to get rid of the coefficient and make sure that it's 1p so that it's solved. So the quick and easy way is to then bring out in front the reciprocal of this. All right, what can be tricky is on the other side, you also want to multiply it by the same fraction. So I multiplied both sides by 3/2. Again, whatever you do to one side of the equation, you have to do the exact same thing to the other side of the equation. So then my 3's cancel, my 2's cancel, and I'm just left with the p that I want. And then when I multiply a whole number times a fraction, I'm probably going to want to put it over 1. Sorry. And I get 5 times 3 is 15. And 1 times 2 is 2. And if you want to give me a decimal, you can. But I like fractions. So in simplifying, I get that p is equal to 7.5. So now I should always go back and check. So what I'm going to do is say does 2/3 times 7.5, is that going to equal 5? And you can just, again, I want this to be quick. I just want this to be a quick check of your work. I don't want this to add to your work. If you throw 2 divided by 3 times 7.5 in the calculator, you should get 5. And then you can say that you've checked it. All right, if you're going to do this the long way, it's better to keep it as a fraction. So this was my 15/2. So my 2's cancel out, and then I'm left with 15 over 3. And 15 divided by 3 is 5. So that's what I want it to be. All right. So if you need to see that example again, you can pause me and rewatch it. It's so important to be able to solve fractions because it's part of it's a solving skill that you need. All right. The next example has the variable on the other side again. So again, if that concerns you, put your hand over the side of the equation that does not have the variable to ask yourself, what is happening to my z? Well, my z is being multiplied by -1/7. So again, I'm going to use the reciprocal property, and I'm going to have to multiply this by, I have to multiply this by -7 over 1. Again, this is the multiplicative inverse. When you flip a fraction, it's going to cancel itself out. So on this side, I also have to multiply by -7. -7 over 1 is the same thing as just -7. So on this side, my negatives cancel each other out, so I get positive, and my 1's cancel out, and I'm just left with I'm just left with z. And on the left side, I'm going to simplify. -7 times -3 is positive 21. I forgot to write my steps for you. So I multiplied by -7, because that's the reciprocal. And then I should go ahead and check. Does the -3 equal -1/7 times 21? And the answer is yes. Because -1 times 21 is -21, and if you divide that by 7, you get 3. All right, I'm just going to do one more example. You can do the last one on your own and get that checked. Sometimes you've got fractions on both sides of your equation, and there's 2 ways you can solve it. I prefer the clearing the denominator way, and that is to, again, only looking at the side that has the variable, you identify what the denominator is, and so, x is being divided by that. So I'm going to multiply both sides by 4 to get rid of that. All right, these 4's cancel, and I'm left with, I forgot there was a -x. I don't care what -x is equal to. So really what I should be multiplying both sides by is -4. So I'm going to change that right away. If you need to do it in 2 steps, it's not a big deal. So now this becomes positive, so I have x equals -4 over 2. -4 divided by 2 reduces or divides out to -2. So again, I'm going to check my work. Does negative of a -2 divided by 4 give me positive 1/2? And the answer is yes. My 2 negatives cancel out to plus, and 2/4 does reduce to 1/2. So I checked my work. You should all get hundreds on everything because you can check your work. All right, so I hope this helped you get started with solving the multiplicative inverse part 2, and that's going to be basically undoing division. You can stop the video now and go ahead and do the last problem by yourself, have it checked, or you can skip back to the other page with me because I do want to go over another way to do that 2/3 p equals 5 if you didn't like that way. So this is the 2-step approach that some of my students like better, and what's happening is p is being multiplied by 2 and then divided by 3. So the first thing I could do, if you want to do this in 2 steps, is I can multiply both sides by 3. That's clearing the denominator first. My 3's cancel. So I have 2p equals 15. And then I have to go ahead and divide both sides by 2 to get rid of that. And I get P equals 7.5 or 15 over 2, just like I did before. So if you don't think that you're strong with determining a reciprocal and worrying about multiplying all those fractions everywhere, this is an alternate method with fractions. All right, so I hope this helps. Let me know if you need any help. Thank you.